So section 10.4, symmetries. And we're going to look at both 2D and a little bit with 3D figures. That's a bit trickier. But we can do some based on the figures that we looked at last week. There's two kinds of symmetries that we look at in 2D and 3D. Line symmetry. Is one, and then rotational symmetry. And to play around with the line and the rotational symmetry, we're going to need the pattern blocks, and we're going to need GeoGebra. So let's grab the pattern block app. So that is available from Activity 10.4a. There's links, and there's the Toy Theater one and the Math Learning Center. And lately, as you guys might remember, I like the Math Learning Center one better. It's cleaner, the figures snap together nice, and I can kind of play around with them in a lot of ways with this nice rotation tool on there. So let's just grab a couple of these on the screen here. See if I can get my pen here to work right. The pen has a scribble mode, right, and it has a line mode. And so looking at these figures here, let's start with the triangle. The triangle already has some lines, right? There's that line there at the base. Now, that would not be a line of symmetry for this triangle. Another triangle in here, and draw another line. I try to draw a line through the top, cutting the bottom like that. This one I do believe is a line of symmetry. So I want to talk about why this bottom one is a line of symmetry and that top one isn't. So let me change colors after. Oh, I gotta do it before. That's okay. So the idea of line symmetry has to do with mirror images. And the book talks about a toy you can play with called a Mira, M-I-R-A, which we can't use virtually, unfortunately. But one way to think about line symmetry is the line forms mirror images. And so when I look at this bottom one right here, it looks like this side over here is a mirror image of this side over here. So that's one idea behind line symmetry. When I look at this line right here, well, I have this stuff above the line, but there's nothing below the line. So this line right here is not a line of symmetry. Another test to see if something's a line of symmetry is related to symmetric points. So I'm going to pick this point right here and this point right here, which feels like the mirror image on the other side. And if I make a segment connecting those, then what I should expect to find is that the distance from this original point, let's call that point A, to where it meets this line of symmetry should match the distance, let's call this one A prime, from this point to that line of symmetry. So I should get congruent segments on each side. Other thing is that line segment that's created by joining these 2 points should be perpendicular. So we have 2 ways to see if we have a line of symmetry. One, does it look like we have a mirror image on each side of the line? That's one test. And the second test is symmetric points. And the symmetric points have two properties. They're equidistant to the line. And two, the segment connecting them is perpendicular. So that's how we would determine if we have a line of symmetry. And we don't always, so we'll come back and play around with that a little bit. Now, rotational symmetry, let's play with the triangle a little bit and see the difference. Let's see. This can go, that can go. And let's change something. I want you to be, how about purple? So rotational symmetry is when I have a figure, and I'm going to put it on top of itself here, and I can rotate it a certain amount around some central point, and I'll end up with the exact same figure before I've gone a complete 360 degrees. So let's see, with this one right here, I can make this rotation right there, and it seems I have the same figure in exactly the same orientation. I can keep rotating a second time and make that happen again. And a third rotation takes me back to where I started. I'm going to try to draw that. So rotational symmetry, the first thing we think about rotational symmetry is what's the smallest angle we can rotate through a central point to end up with the same figure in the same orientation. So smallest angle to rotate a central point to get same orientation. So when I think about that rotation here, my central point's there. I'm going to rotate this point to there. That was one way to get there. And then I could do that again, and a third time took me over there. So all three of these make 360 degrees. So 360 divided by 3 is 120 degrees. So I would say this figure right here has 120 degree rotational symmetry. And every figure is different. Some figures have line symmetry and rotational symmetry. Some figures have many lines of symmetry and many rotational symmetries. So this one has a 120 degree rotational symmetry. If I go 120 and 120 again, it also has 240 degree rotational symmetry. And mentioning 360 degree rotational symmetry is pointless because everything, if you rotate it 360 degrees, is exactly where it started. So 360 rotational symmetry is not a thing, not a thing. As far as lines of symmetry, some figures can have more than one line of symmetry. So let's go back to this triangle. So we get the basic idea of what line symmetry is. We get this basic idea about rotational symmetry, and now we're just going to play around and get used to these ideas. So that triangle, let's grab the green version. many lines of symmetry. And remember, a line of symmetry has to give us a mirror image, and we can also double check by finding symmetric points. So I'm just going to go back to pull this up a little bit first. Oops. Easier to draw on. There we go. And I'm going to go back to that first line of symmetry, which was perpendicular to this base down here. So that, again, this line right here. And any point can be a test point to check if this is really a line of symmetry. So for example, I could pick, say, this point over here. And to find out if this figure is symmetric, this is a line of symmetry, then I would want to find its symmetric point perpendicular through there. So I'm just going to draw my best perpendicular line there. And this is what I think the symmetric point should be. And without some other tools to measure at the moment, I'm just going to look at this and say, well, that looks like a right angle right there. And this distance right here looks like it matches that distance right there. So this looks like a line of symmetry. That one right there. And remember, last time I picked a convenient point, which was this one down here, and thought that should be symmetric. And when I connected the two of them, it did seem that I had this right angle here, and that this length matched that length right there. And so it shouldn't matter which point I pick, I should always be able to find its symmetric partner on the other side. And that looks like a Christmas tree. Now, again, a figure can have more than one, so let's take this a little farther. And identify if there's more than one. So for sure I have this one vertically down the middle. There's that one right there. But there's nothing special about this vertex being on top. I could focus on this vertex over there. And so if I try to draw a line through the middle of the bottom, that looks about right. I think that blue line is a line of symmetry too. And then I'll be able to see green on green here. If I go from this point here, yeah, and I aim for that middle of the bottom here, looks like I have another line of symmetry. And this is kind of cute. The three lines of symmetry meet. Now, if I try to draw any other line, things aren't going to work out so well. Like back here, I had tried to draw this line through the base. That is not a line of symmetry. That didn't work. So I think what we'll find is any of the lines we try to draw aren't going to work out. Let's double check this blue line right here. If I wanted to check the blue line right there, I kind of want to ignore the other two and ask myself, does it look like the blue line makes mirror images on each side? Or if I pick a point, like on this side of the blue line, like maybe that point right there, does it have a partner point on the other side such that when we connect those 2 points, that two things happen. We form a right angle between the segment connecting those points. Maybe this point is B, and this would be B with a little apostrophe. We usually say B prime for that. And does this distance here match that distance there? So I can try to measure those with a ruler to see if they mark up. So to get more technical about determining if it's indeed a line of symmetry, a couple of things would need to happen. One, we would need some way to measure angles and a ruler. Or two, we could use some other bits of geometry like a compass and a straight edge, which I'm going to talk about in the next class. Or we need some kind of tool like GeoGebra to test this stuff out. And so we'll try building some stuff in GeoGebra in a moment. But here I see 3 lines of symmetry. Let's try another figure. Let's pick on, let's clear some space here. I'm at the pattern block app here. I can put that in the video description for those of you in the future. Let's try the hexagon and look for lines of symmetry on it. And so we'll try to draw some lines that are and are not lines of symmetry. So the first thing I need to do is put this somewhere I can draw on it. And you can draw on this screen even with a mouse. So I'll do that too, just for fun. New page for this. Come back to you. So remember, in this app, I have this pencil tool here, and the pencil tool allows me to scribble or draw lines. And right now, it looks like it's going to draw blue, which should look good with that. And you know, I could wonder, well, for sure, it looks like I could draw a line through the middle. Right? That happens with a lot of figures, the way we orient them. So, and that's pretty close. Not perfect, but not bad. So I think this is a line of symmetry here. I think that this point right there is symmetric to that point right there. So I think the segment connecting them in between here is both perpendicular. Let's see if I can get a new color for this, a little green. It's both perpendicular, and the 2 segments separated by the line, this one and this one, appear to be congruent to me. And the same thing looks like it would happen down here. If I pick that point there and that point there on the end, and we connect them with a line segment, that line segment does seem to make perpendicular to the line of what I think is the line of symmetry, and the 2 pieces on either side of that line do seem to be congruent, and that's what these lines mean, congruent. Since I put a single line above, I should use a double line to say this is a different congruence here and here. So I think I got 1 line of symmetry there. Are there others? So I think I need a new version of this guy to think about that. Often lines of symmetry come from a vertex on a polygon. So if I tried to say connect this vertex here to that one there, does this form a line of symmetry? So to test that, I'm going to pick a point and see if I can have a symmetric point to it. So what if we picked this point right here? And then we would want to go through that perpendicular looking for a symmetric point. So let's see, is that about perpendicular there? And then, could that right there be a symmetric point to the other one? Now, you could get lucky just once, and I think I just got lucky here, even though I didn't mean to. So for example, if I pick this point right here, and this is going to be true for every single point on the figure. It has to have a symmetric point in the same place on the figure. And I go through. Oh my, look at that. That looks like it probably matches up there too. Is this green line really a line of symmetry? Let's keep trying. If I pick this point right here, and I go perpendicular to the green line, oh no, that doesn't work. Yeah, this length up here is not the same length as that down there, even though I tried to make it perpendicular. All right, so all I have to do is find 1 point where it fails. So I got lucky, I found 2 points that seem to have a symmetric partner, but then once I get over here, that didn't work. And you can see, like if I get over to this point right here, and I go to find its symmetric partner, so perpendicular to that green line, its symmetric partner would be way out here. There ain't no points out there. Right. So that green line is not a line of symmetry. here. Ooh. Not a line of symmetry. So I could try to draw a line from this other upper vertex to that lower one, and this is just a reverse of the problem I have there. And then I might wonder, well, if I have one vertical through this, might they bring one horizontal? And often it's obvious to us because we have a lot of experience with life and figures and stuff. Kids have a little less experience than us. It's fine. Try to draw a line horizontally through the middle here. Kind of right there. Is the top a mirror image at the bottom? The answer is no. And we could kind of see that here. There's no mirror image stuff going on here. This thing is not replicated down here. Right? That didn't happen. So no, that's not one either. So it looks like this one only has one line of symmetry. So some figures have more than one, some figures have one, some figures have none. It's possible to have no lines of symmetry in a figure. So let's put this in the notebook here too. So right through the middle there. So this seems to be the line of symmetry. Right about there. So on this one, we were only able to find one line of symmetry. All right, so next let's consider rotational symmetry for this thing. And I'm gonna first try to do that without using that app, just by kind of looking at it and guessing. So the center of this sucker should be right around here. So we rotate through its center. And imagine we rotate that point right there. How far do I have to rotate till I get exactly the same figure back? Well, if I try to rotate this whole thing down that way, right, this looks nothing like that vertex. So heading out 90 degrees-ish, coming around to 180 doesn't even look helpful. I'm thinking that I'm gonna have to get all the way back to where I started for rotational symmetry. That's where it's nice to have these things in front of you. So normally we'd be in a classroom and we have the physical toys in front of us and we're trying to rotate them to see what's going on with them. So let's put a new one down here. And the nice thing about this app is it gives us this little rotator through its center. And so I want to grab that thing and I want to spin it till I get the figure exactly the way it was. And here I am, 90 degrees. That's not the way it was. That's not the way it was. That's not the way it was. I have to go all the way back to where I started. So I have to make a full 360 degrees. If that's the case, you don't have any rotational symmetry. Everything rotated 360 degrees is back to itself. So no rotational symmetry on this sucker. All right, let's take a look at the activity. So the activity here, a couple of things. We want to identify lines of symmetry, and we need to make some sketches to figure that out. Those sketches could be done on paper or they could be done in the app here. And we also want to identify rotational symmetries if they have any. So for example, let's see, we just did this trapezoid here and we did the triangle here. So the triangle we found had 3 lines of symmetry. The trapezoid had 1 line of symmetry. Trapezoid had no rotational symmetry, and the triangle had 120 degree rotational symmetry. And when we name the rotational symmetry, we usually just name the first rotation we found that gave us symmetry. And there's an interesting connection between line symmetry and rotational symmetry that hopefully we'll see after we do a bunch of examples. So we'll do one more of these in just a moment. Now, the second part here, I want you to create a figure, any figure you want, and then I want you, based on that figure, I want you to explore if it has any symmetry at all, line symmetry or rotational symmetry. So I made this figure right here by sticking together 2 trapezoids and 2 of the blue rhombi here. And I made this new 6-sided figure here. It's a hexagon. And if you examine the hexagon, you'll find that it's not regular, but it is equiangular. So each of these angles here are 120 degrees as we come around this figure here. And the only symmetry I see out of this is if I just rotate it 180 degrees, so this top here becomes the bottom, that's the only symmetry I'm going to get. And otherwise, I saw 2 lines of symmetry through this, and I'm describing them here. I saw one vertically cutting it in half, and one horizontally cutting it in half. So then your goal is to create a couple of other shapes, and they may have symmetry or may not. So I'm going to do one more of these here, and then I'm going to make up another shape here and see if I can explore the symmetries in the pattern blocks. A new page. And if you wish to share any of your pattern block work, remember how this works. When you do use the share feature here, it only shares what's on the screen. And if you do anything after, you would have to do a new share for that to be seen. So for example, let's see, which one do I want to do? How about we do this guy down here, this skinny rhombus. I'm going to play with this one here, and I want to identify its lines of symmetry. And so I'm going to bring up my line tool. And one place to start is, I mentioned earlier, is if you just connect vertices, sometimes that leads to lines of symmetry. So if I draw a line from there through the other one, it does look like I made mirror images on each side. So there's one line of symmetry there. And then if I do the same thing, and notice I'm starting at a vertex as to far away. It's harder to start out here and hit things right. So, oops, I need to start over. Let's put this one back in. So trick, start at a vertex, aim through the other one. So there's what I think is one line. Maybe I use green for the other. So starting at another vertex, those both look like lines of symmetry to me. So I see 2 lines of symmetry coming through this thing right here. As far as rotational symmetry, often what I do is I make 2 versions of it and just color them a little bit different to kind of see where one sits on top of the other. And with the kids, I just have them grab a couple of toys and play with them at the same time. So this one right here, I'm going to color. Let's make it so purple again. And I just want to grab it and then rotate it till it sits back on top of itself. So starting up here, right, I'm pointing upward, 12 o'clock. And I get down to 3 o'clock, and I got nothing. And it's not till I get all the way back down here to 6 o'clock till it sits back on top of itself. So I rotated from 12 o'clock down to 6 o'clock. That would be half a rotation. So it looks like I have 180-degree rotational symmetry there. So what do I see here? I see 2 lines of symmetry. Opposite vertices. So I just want a little description. So that's describing that. And then here, I can just describe it. You know, all I can really say is I see 180. 80 degree again, that's something physical you have to do, so it's kind of hard to say anything, but that's what we found. And again, if you did want to share something as opposed to just typing this up in a Google Doc, which would be easy, or you could do screenshots of these. If I share at this point, so for example, I'm just going to stick this in the chat, copy. So this is this in what gets shared is only what I have at this instant in time. So let's show that by bringing up a new tab with it. So when I grab that link and look at it, I get a copy of what I have here. And if I change anything here, like, I don't know, maybe I want to show it like 180 degrees to itself like that as kind of my evidence, that's not going to be present here in this new one, right? So this is a different one. Let's put in a new screen here. Oops, come here. There you go. All right, so I have these two different versions of it now. This is the one I shared out. This is the one that's in the YouTube video, and this is a new modification of it over there. So if I wanted to share this version, I got to get another link. And then I have a new code. That code is in the share link here. So this doesn't work the same way Google Docs, Google Drive stuff does. Google Drive, the link is always the latest version. Here, every time you make a link, it's a snapshot of that thing in time. So just an important note about using this app right here. All right, so those of you with me now, any questions about what needs to happen here? So we've done 1, 2, 3 of these. And I encourage you when you're working on this to take risks and try to find as many lines as possible and look for things that may or may not be lines of symmetry. So I'm gonna make a new one for the second part here, just playing around with the figures and see what happens. So, oops, let's go new one. And every time you click this link, it gives you a new page that you could share out in the future if you want. Full screen. Full screen. There you go. So let's see. What am I going to make? I can grab this one here. Stick that on top there, and then let's grab this one and put it right there. So now I want to know, does this thing right here, so this is my new shape, does this have any lines of symmetry? And does it have any rotational symmetry? So I'm actually going to scribble on it in my other notepad. It's a little easier to write there for me. Do I have any symmetry here? And so then I just kind of play around. And usually if I have something on paper, I'll get another piece of paper to line up to it. So I think, all right, well, is this a line of symmetry? No, right, there's no mirror of this side triangle on the other side. So that doesn't work. Is this a line of symmetry? Should have been a little higher, but no, it doesn't work that way. Connecting opposite vertices, maybe from here through there is a line of symmetry. And the answer is no, this would have to be present on the other side. So if this were a line of symmetry, then I'd be expecting to see some mirror image triangle over there on this side. So that when I connected this point to that point, they would make a perpendicular line. Right, oops. If that was a line of symmetry, but there ain't no triangle over there. That's not a line of symmetry. I don't know. You guys see anything here? Is there something I'm missing? You see a line of symmetry? I haven't connected all vertices, right? So maybe there's another connection. Oh, I think I see one. What if I went from here through there? Is that a line of symmetry? Does that look like a mirror image? I think it does. think this point over here is the mirror image of that one. This point here is the mirror image of that one. And my line's not quite perfect there. Fix that. Redraw that. Maybe I'll get it better the second time. That looks a little better there. And so just double checking that feels like a mirror image on each side of this line here. So that this part right here is a mirror image of this part down there. Let's see, so I'm just going to test those a couple of points here to see if they do feel like they're symmetric. So this point to that point right there should make a right angle, and that looks like a right angle there. And then this length looks like it matches that length. Yeah. And this here seems like if I connect those 2 points, I got that right angle to the line, and I have congruent segments on each side. Yeah, all right, this has one line of symmetry. Unless you see something I've missed. And again, the only way to tell is just to experiment. And so often I redraw a figure, try again. Is there another line I could draw here? That's a line of symmetry. So often we get lucky by going through middles of sides, and I tried that vertically and horizontally, that didn't work. I tried going through these 2 vertices, that didn't work. These 2, that seems to work. And if I do anything else, like maybe connect this vertex here to that one there, what's above is not a mirror image of what's below, right? So, nope. I think we just have the one line of symmetry. Now think about rotational symmetry here. For rotational symmetry, I could imagine finding a central point. So where's the center of this thing? Over here, over there. I'm going to call this the center, right here. Across there. So that's about the center of this thing right here. And so then we rotate. So imagine this point rotates. When will it? When will I be able to rotate this around the center and get us the same orientation on the shape? And really, I don't. This will let me rotate, won't it? It won't rotate around the right point, but we can kind of see what's going on. When is this one going to be back on top? I mean, this one's on top now, but now that's on the wrong side, right? It should be on the other side. So 90 degrees doesn't work. 180 degrees down here, nope, that's not the same shape. This would be 270 degrees. Oh, this counts in the other direction. So just a note, I think I mentioned this a while ago, often when you're measuring degrees, positive is counterclockwise, which is kind of weird. So if I grab this again, it's going to start at 0 there and then start counting positively. See that little counter on my drag? Yeah, so it looks like, yeah, the only time I'm going to get back to where I started is 360 degrees. So this has no rotational symmetry. So play around, make some cute figures that have some symmetry. See if you can make a figure that has no symmetry at all. Right? Mine had one line of symmetry and no rotational symmetry. Could I make something that has no symmetry at all? It shouldn't be too hard. So let's see, that had symmetry right there. One easy thing to do would just be, stick some other figure on it like that right there. Does that have any symmetry? Vertical line, nope. Horizontal line, nope. I can't come up with any kind of diagonal looking at it. I think that has no symmetry at all. And that's okay. Some things have no symmetry. For some reason, we humans seem to like symmetry. I've always been fascinated by it since I was a kid. A lot of drawings I would make when I was little have lots of symmetry to them. Some things have no symmetry. All right, let's go and play in GeoGebra a little bit. So again, this activity, relatively straightforward. You want to play around by drawing on these objects, either on paper or use the Math Learning Center drawing tools to kind of play around and find as many lines of symmetry as you can, document them, and find out its rotational symmetry, which we usually get by identifying the first angle of rotation that gives us the same orientation. And then create, from those basic shapes, 3 new shapes and tell me about their symmetries or lack of symmetries. So that's this activity here. You can do screenshots in Google Doc. You could draw it out on paper. If you draw it on paper, try to be neat. These are hard things to draw. So screenshots in Google Doc might be the way to go. And you can also share. The downside is it's hard to do too much at once. Like I used up a whole screen here just to talk about the red trapezoid here. So that would have a lot of different share pages. Okay, let's play with GeoGebra a little bit. We haven't done that in a while. Search. Let me start a video first.